And as I've mentioned to you previously, the final ionic molecule that's formed has to be electrically neutral. So with this in mind, let's turn to the chemical formula of ionic compounds. And there are 4 steps that you can follow. So let me illustrate this for you using the concept of, or the example of magnesium oxide. Okay, so step 1 is to write down the symbols for the metallic cation and metallic anion. So the magnesium is here and oxygen is here. Step 2 is to determine the group number of each atom from the periodic table.
Okay, so since magnesium is from group 2, and for oxygen it would be group 6.
Step 3 is to determine the charge that's formed by each ion.
Okay. Since magnesium has 2 valence electrons, as we can tell from the group number and also over here, it will lose 2 valence electrons to form a cation with a 2+ charge. And for oxygen, since it has 6 valence electrons, it needs to gain 2 more to be stable. So it will form an anion with 2- charge.
Yes. And the final step is for us to determine the number of atoms that will be required for each element so that the final compound is electrically neutral. So over here, you will need 1 of the 2+ charge to be neutralized by 1 of the 2- charge, right? So therefore, the final formula for magnesium oxide will have to be 1 from magnesium and 1 from oxygen, because they will come from an Mg2+ and Mg2-.
Yes, okay.
Okay, so why don't you try calcium chloride?
So step 1 is to write down the symbols for each element. So calcium would be Ca, chlorine would be Cl. And Ca belongs to group 2. I'll just write down the electronic configuration as well. 2, 8, 2. And for chlorine, it is group 7. It would be 2, 8, 7. And step 3, I determine the charges formed. So for calcium, since it has 2 valence electrons, it will lose 2 to become a cation with a 2+ charge. Whereas for chlorine, it needs to gain 1 more to be stable. So it will form an anion with 1- charge.
Yes.
And when we balance the charge of 2+, we will need 2 of the 1-.
That's right.
Final chemical formula would be CaCl2.
Okay, so that was correct, but please do take note here. When there is more than 1 of a particular anion like this one here, the number should always be written as a subscript. That means you shouldn't write it too large.
Then I should change it to Cl2 like this.
Yes, that's right.